Imagine a research and strategy team tasked with gathering insights on a specific industry trend. They need to collect relevant sources, check their credibility, summarize the key findings, and turn them into a cited report. Our autonomous web research analyst is designed to handle such requests efficiently. For instance, the team might ask the analyst to research the impact of artificial intelligence on the job market. The analyst would then spring into action, scouring the web for credible sources, including academic journals, news articles, and expert opinions. The user boundary of our product is straightforward. The research and strategy team submits a request, and the analyst provides a comprehensive report in response. The input is a simple query, such as, "What are the effects of AI on employment?" And the output is a detailed report, complete with cited sources, summaries, and analysis. This report would be tailored to the team's specific needs, providing actionable insights to inform their strategic decisions. Behind the scenes, our product relies on a sophisticated architecture that leverages the strengths of several open-source repositories. Obscura, a lightweight and stealthy headless browser, is responsible for web scraping and automation. Its ability to run real JavaScript and support the Chrome DevTools protocol makes it an ideal choice for navigating complex web pages and extracting relevant information. Agents Towards Production, on the other hand, provides a framework for building production-ready AI agents that can scale from prototype to enterprise. These agents are capable of performing tasks such as stateful workflows, vector memory, and real-time web search APIs. Pipeshub-ai, an open-source workplace AI platform, plays a crucial role in our product's knowledge graph retrieval and permission-aware search capabilities. Its explainable answers and enforced access controls ensure that the analyst provides accurate and trustworthy results. Gridex, a local database IDE, supports 7 database engines and provides a built-in MCP server and AI chat, allowing our product to efficiently manage and query large datasets. Finally, Grafana, an open-source monitoring and dashboard platform, enables the creation of dynamic and reusable dashboards, providing a clear and intuitive visualization of the research findings. As our autonomous web research analyst processes the request, it seamlessly integrates the capabilities of these repositories to deliver a comprehensive and insightful report. By leveraging the strengths of each component, our product provides a powerful tool for research and strategy teams, saving them time and effort while delivering high-quality results. With its robust architecture and cutting-edge technology, our analyst is poised to revolutionize the way teams conduct research and make informed decisions. A research team initiates a query through a pipeshub-ai endpoint defined in Agents Towards Production, specifying topic parameters and source requirements. This triggers an event handled by a stateful agent, which constructs a scraping plan. The agent invokes Obscura via its CLI API, passing URLs and headers. Obscura's Rust binary launches a headless session, randomizing fingerprints to evade detection while fetching pages in 80 FIMAs. Raw HTML and metadata are returned as a JSON payload to the agent. The agent processes this data using pipeshub-ai's local LLM integration, parsing content into structured facts. It calls pipeshub's ingest endpoint, authenticating via Auth2, to store verified sources in a permissioned knowledge graph. Pipeshub's graph database creates nodes for entities, for example companies, technologies, and edges representing relationships, attaching cryptographic citations back to original URLs. This graph is stored in a PostgreSQL database managed by gridex, which optimizes schema and indexes via AI-generated queries. The agent then queries Pipeshub's search API to gather relevant context, using its permission-aware system to filter access based on team roles. Results are synthesized into a draft report, with citations embedded as JSON blocks. This draft is stored in Gridex's SQLite repository for version control, leveraging its built-in AI to suggest additional data points or conflicts. Finally, the agent triggers a Grafana dashboard refresh by sending an event to a Grafana Alert Manager compatible endpoint. Grafana queries Gridex's PostgreSQL database through a secure data source plugin, rendering visualizations of source distribution, sentiment trends, and key entities. The final report is exported as a PDF with embedded charts, citations, and raw data appendices, all hosted internally with access logs audited via Grafana's built-in monitoring. Each service enforces strict boundaries. Obscura handles unauthenticated web interaction. Agents towards production manages workflow orchestration. Pipeshub owns knowledge graph integrity. Gridex controls database abstraction. And Grafana presents analyzed insights. The data flow moves from raw scraping to structured storage to visualized intelligence without leaving the team's infrastructure, ensuring compliance and traceability at every step. To build a functional MVP, start by integrating Obscura for web scraping and browser automation. This will enable the collection of sources from the web, which can then be checked and summarized by the AI agents built using agents towards production. The output from these agents can be fed into pipeshub-ai for knowledge graph creation and explainable search. Meanwhile, use gridex as the backend database to store and manage the data, leveraging its AI-native query suggestions and optimization capabilities. For local development, set up a Docker environment with all the necessary dependencies, including the various database drivers supported by gridex. This will allow for seamless switching between different database engines during testing. Write unit tests and integration tests to ensure each component works as expected, using a testing framework that supports asynchronous testing. For example, when testing the Obscura integration, use a pseudocode like fetch webpage extract content, assert content length is greater than 0 to verify the scraping functionality. Background jobs can be used to handle tasks such as scheduling web scraping, updating the knowledge graph, and running AI agent workflows. Use a job queuing system like Celery or Zato to manage these tasks, allowing for easy scalability and retries in case of failures. When a job is run, it can trigger a series of actions, such as scrape webpage, update database, trigger AI agent workflow to ensure a seamless flow of data processing. For production deployment, set up a cloud-based infrastructure with a container orchestration platform like Kubernetes. This will enable easy scaling, rolling updates, and self-healing in case of node failures. Use a cloud provider that offers managed services for databases, such as AWS RDS or Google Cloud SQL, to reduce the operational burden. Deploy the application behind a load balancer, with SSL termination and HTTP2 support for secure and efficient communication. Monitor the application using Grafana, creating dashboards to track key metrics such as scraping throughput, AI agent performance, and database query latency. With this setup, the application will be able to handle a high volume of requests, provide real-time insights, and scale as needed to support growing demands. To tie these components into a cohesive autonomous research workflow, start by deploying Obscura as your stealthy scraping engine. Download the binary from their GitHub releases, then run Obscura, headless to initiate stealthy data collection with automatic fingerprint randomization. Environment variables like obscura proxy list can rotate residential proxies for scale. For production, Obscura Cloud requires a paid plan starting at 0.10 GB traffic, but the open-source binary remains fully functional under Apache 2.0. Next, integrate agents towards production by cloning the repo and running npm install to access its production agent tutorials. Use Docker to containerize workflows, Docker build to research agent, followed by Docker run to deploy stateful agents with built-in web search APIs. This framework is unlicensed in its README but appears permissive, attribute properly. For knowledge management, self-host pipeshub-ai using Docker Compose as outlined in its deployment docs. Set pipeshub-ai compliant true to enforce audit trails. While the core is open source, license unlisted but implied permissive, enterprise features like SSO may require paid support tiers. Gridex connects directly to your databases via its universal binary. On macOS, install the DMG, then configure connections through its native UI. For AI-powered SQL suggestions, enable the built-in MCP server via gridex. MCP listen localhost 134. It's licensed under Apache 2.0 with no costs beyond infrastructure. Finally, monitor everything with Grafana. Install via brew tap Grafana and brew install Grafana on macOS, then configure data sources through its web UI. The MIT licensed platform is free but requires setup time for dashboard customization. One concrete build step: clone agents towards production, run npm and install, and execute the Dockerized Research Agent tutorial to test web scraping integration with Obscura. If you're concerned about detection evasion, how do you plan to rotate user agents or manage proxy failures at scale?